Hello everyone and welcome to the applications of quadratic equations video. One of my better ones, he says, hopefully, because I haven't recorded it yet. My name's Darren from, yes you know, mathsguru.com, and it's my honour to be able to present videos to you. I love doing this type of thing, and hopefully it gives you everything you need to smash maths. Now, to be able to record these videos, I need a little bit of help from you, and that's to have you subscribe to my YouTube channel. I know I'm a bit of a loner, I don't leave this room, the dog's lying here fast asleep, and I'm talking to myself. And I do lose faith sometimes in the fact that I'm doing this for nothing. But then people subscribe, and it really does make me feel really, really good. If I get 3 subscribers at the end of the day, I tend to run around like a lunatic. Sad, but true. Shall I finish this waffling? Absolutely. But again, have I said mathsguru.com? Everything I'm about to write down behind me, you can download as a PDF for your summary books or whatever, along with all the videos for this series and so much more. God. It's an awesome little website, if I do say so myself. Now, learning objectives. Come on, guys, you can pause the video if you need to. But those are the learning objectives. It's going to build on the knowledge we had previously. And what knowledge is that? 'Tis this. So far, we have looked at the general idea of what a quadratic is. And if you don't know what, it's the first time you've watched this video, head over to Maths Guru and just have a look at the previous videos. This is such an important topic for now and later on, probably in life. You know, I can't imagine the time you won't be wanting to walk down the supermarkets and trying to look at, you know, how to apply a quadratic equation to, you know, the price of tins of beans. It's just so exciting. But what we've been doing is looking at how to solve quadratic equations. And we've noticed that there are certain general ways or certain ways that quadratics can be written. It's just got the x squared term in. So in this one here, it's just the x squared and a number. Here, it's got an x squared term and an x term, but no constant. Here, it's got all 3 of them, x squared and x and a constant. And the fact that it's equal to 0 basically just means that we're going to find solutions. We're finding where it crosses our axes, because that's really what becomes important. By knowing those points, we can sketch graphs, yes? And we can obviously then choose to either do a square root, to factorize, to do the T method, depending on which form they give here. And you've got to sort of do a little bit of detective. You've got to become sort of a little bit of a sleuth to try and work out and look at it and go, that's just an x squared, I'm going to use this. That's an x squared plus an x, I'm going to use this. There's an x squared and an x and a number, I'm going to use this. But always know that when we have a quadratic, it can have 2 solutions, like this one does here. It can have 1 solution, like a perfect square will. Or it can have no solutions, where it doesn't go anywhere near the x-axis. And again, a solution is where it crosses or touches the x-axis. Right, that's recapped all the previous stuff. Shall we continue? Yes. Now, I know that when we say word equations, everyone goes, ugh. And I wish I could show you an example of every word equation on the planet. I can't. We wouldn't leave. We'd become very good friends. But, you know, the video would be way too long. So what I'm going to do is show you examples or some of the best examples out there that really we just adapt as maths teachers. If you look at these examples, they should put you in good stead. Don't worry so much about the example, worry about how I'm extracting the maths, because that's testing your understanding, not regurgitation. I'm so sorry, guys. Maths really isn't about regurgitating, it's about understanding, yeah? Being able to do things forwards and backwards. Right, let's have a look at some of the obvious ones. Now, first things first are area problems. We love these, giving you area problems. So here's just one example. The length of a book is 4 centimeters. My maths teacher at school said, a diagram is worth 1,000 words. He didn't talk like that. Maybe he did. And I was like, you what? Draw a diagram. Draw a picture of a book. Now, I'm not talking about an artistic one. You know, I'm not much of an artist, but there's my book. End of. The length of the book is 4 centimeters more than its width. Now, looking at this here, that would be clearly the width. That there is the length, but they haven't told me the width. I know the length of the book is 4 centimeters more, but I don't know what the width is. And this is where we sort of trick you, because you've got to come up with the letters that you're going to use to be able to sort of help solve this question. And because all of the letters we tend to use in this chapter are x, I'm now going to call the width x. Now, if we know the width is x, then I know the length is going to be x plus 4. Yeah, because it says there, it says the length of a book is 4 centimeters more than the width. Okay. The area of the face of the book, okay, good. So the area of here is 320 centimeters squared. 320 centimeters squared. Now, by drawing a diagram, my mind is suddenly going, well, hold on a moment. I know how to do area. Area is that times that, isn't it? Oh, well, I know I've got this is an x, and I know I've got that, which is a times, so I can write that out. So your next step would be to say, well, I'll do x times x plus 4 equals, well, that's how to find the area, but they've told me the area is 320. Next step is probably the critical one, because at the moment, a lot of people then go, oh, I can use the null factor law. No, you can't. You can't use the no, please don't use the null factor law. Why can't you use the null factor law? Yep, because that's not equal to 0. All right, so again, that's the trick. I know we've got two things multiplied by each other, but that is not equal to 0. So what we have to do now is expand. So get x squared plus 4x equals 320. That's not written as a standard quadratic, so we're going to change things and take away 320 from both sides. And now I have a quadratic I can solve, yes? Obviously, I'm going to have to use my t method. So here is my t method. I'm looking for minus 320. Now, a lot of people go, oh my God, this is going to take forever. Okay, what else are you going to do? Right? If you're in a maths lesson, you've got to be there for an hour or 50 minutes or 2 hours. You may as well just suck it up. All right, go to Bunnings, buy some concrete. So 1 and 320, 2 and, here we go, 160. 3, nope, 4, yes, 4 is going to go into there, 4, 8, 12, 16, 20, 24, 28, 60 times. Is 5 going to go into there? Yep, 5 is going to go into there how many times? 5, I don't know, 5, 10, 15, 20, 25, 30, 6, is 4 going to go in there 60 times? Or is it 80 times? Let's try that one again. 4's into 320. 4, 8, 12, 16, 20, 24, 28, yes, 80. All right, I know you're screaming. I didn't say my mental maths was very good. Right, what about 5s? 5, 10, 15, 20, 25, 30. It's going to go 6, remainder 2, so 64 times. 6 is going to there. 6, 12, 18, 24, 30. No, 6 is 7s, 8s. What about 8s? 8, 16. That's going to be 40. We'll be getting closer to 4. And obviously, we're just trying to get it down to 4 here. And, you know, again, it's trial and error. What about 9? No, 10. 10's going to there. So 10s and 32. 11s, 12, 24, 36. And by this time, literally, I'd be grabbing my calculator because my brain is now frying. I'm going to fire up my calculator and try and work out all the numbers that go into 320. Bear with me while my calculator fires up. All right, so firing up my calculator. Again, I'm going to use a CAS calculator. Many of you out there probably won't have a CAS calculator. That's okay. It still does the main function. So 320 divided by 12. Nope. 320 divided by 13. Nope. 320 divided by 14. And I'm just going to keep going. 320 divided by 15. 320 divided by 16. Oh, how's that looking? 20. There we go. So in this situation, turning it off, it's going to be 16 and 20. So I'm going to write 16 and 20 there. Now, the reason being here is we now want it to make plus 4. So the numbers have to multiply to give a negative, but add to give positive. So in this situation, I'm going to make that minus 16 and 20. Yay! Oh, I don't know why I made myself so big there.